So welcome to our live training. In this session, we're going to be creating a casual jewel mining style game. Basically what we're going to do is we're going to have a little rotating turret, which can fire a kind of a grappling hook, which will connect with a jewel or a rock and pull it back to the turret. And you're going to score points for the jewel, but not for the rocks. And there will be a timer that is going to run down to make it more difficult. So you should be seeing a picture of that, a still image of that on the screen now. That's what it's going to look like. And so let us dive right in. So you should be seeing a blank Unity project right now. And so this is a project that I initialized with the 3D defaults. You could totally do this game in 2D, and this is actually effectively a 2D game. I just figured it would be a little easier to do with cubes and stuff to avoid having to use a bunch of art assets that I don't have. And so there is one asset that we're going to use, which is the gem shader asset, which you should be seeing on screen. This is a free asset which you can get from the publisher Unity Technologies. Just search gem shader on the asset store. We're using Unity version 4.61 for this. It's important to have something later than 4.6 so that we can use the UI functionality, which we are going to be using a bit for score and stuff in this at the end. So let's dive right in. So we've got just a blank scene here. I'm going to start by creating a game object, light, directional light to light our scene. And I'm also going to create a cube. This cube is going to represent our miner turret. So I'm going to take that and position it at +5 on the y-axis just by clicking on the transform, typing 5, and there we go. We're then going to attach a little sort of turret shooter thing to it, which we will call gun, which is just going to be a child of our first cube, which we'll label miner. And the gun is going to be small. It's going to be 0.2, 0.2, 0.2 on the X, Y, and Z. And it will be at negative, what do we want? Negative 0.6 on the Z or Z axis. So it's just going to be a little kind of nub sticking out there just so we can see what our miner is pointing at and what it's going to shoot at. While we're at it, we will add another empty game object. We're going to choose create empty child on the miner. And this is going to be, on the gun, not on the miner, on the gun. We're going to create empty child on the gun. And this is going to be called origin. This is where we're going to be shooting our grappling hook from. And we're going to create one more cube. This is going to also be a child of the gun, and we can actually just copy component for the transform for the gun and paste component values into the transform of our new cube. Whoops, actually that didn't work. No, don't do that. We'll just do it manually because that is relative to the gun. We'll just create a cube and we'll call it claw. This is going to be the projectile that we're going to shoot out. This is going to be 0.2, 0.2, 0.2 as well. And then we'll child it to the gun. And it's going to be at about negative 1.5. So just a little bit below the gun. So we've got the miner. The gun is a child of the miner. The claw is a child of the gun. And the origin is also a child of the gun. And the origin is just a empty transform. We're just going to use that basically as a spawn point. Okay, so now that we've got that, we're going to create one other cube, and this is going to be just a kind of a barrier at the bottom of the level. So we're going to set this to -6. We can jump over to the scene view so we can see it. And then this is going to be a scale of 50 along the x-axis. So this is really just kind of our barrier that we're not going to be able to shoot our grappling hook past. And we're going to set it to is trigger and remove the mesh renderer because it's just going to be an invisible box. Actually, it doesn't need to be a trigger. That's fine. The claw, however, is going to be a trigger. the claw is also going to have a kinematic rigid body. It's going to be a moving object, so it needs to have a rigid body. We're not actually going to be using physics here. We're just going to be setting the transform by a script, but we still need to have a rigid body because it's going to be moving. And so we're just going to add a rigid body component. That's add component, and then just type RI, rigid body will pop up at the top of the list. It's not going to let me add it twice. And then we're going to uncheck use gravity and check is kinematic. All right, so now that is good for those. Let's add our gems to our scene, and we'll actually make prefabs of those. So we're going to create a folder called prefabs, and we will go into the gem shader folder, into examples, and into sources, and you will see these 4 diamonds. I'm going to command click on a Mac or control click on PC to add those to a selection. And somehow I got the folder selected too. Command click each of those. And we're going to set the scale to 0.3 for each of these for X, Y, and Z. And then we're going to turn off use gravity and turn on is kinematic for the rigid body as well. We're also going to add a tag to these. So up here, they're currently untagged. So I'm going to go to tag, add tag, and this tag is going to be called Jewel. And then the next tag that we're going to add, which we're going to use later, is going to be called Rock. All right. Now, let's jump back out, reselect these, and apply the tag, right? This is something I forget to do all the time. I define the tag and then I don't apply it. So we're going to apply that to those 4, and then we'll just move them over to our prefabs folder so that we can have them handy. And let's add them to the scene. We'll just drop them in and make sure that they are at 0 on the Z or Z axis, right? We want to make sure that they're all lined up on the same Z coordinate so they don't get like, forward or back, because basically we're going to be working on this one sort of plane. All right, let's look at our game now. Okay, so there we go. So we've got our kind of basic pieces that we're going to need. I'm just going to change the background for the camera to make it a little sort of sandish, dirtish, sandish kind of color. Maybe a little less saturated, something like that. There we go. So I'm just changing the background color for the camera just to change that. Okay, and while we're at it, this is just silly, but I don't know, I like to do these kind of things. I'm just going to add a cube and use it to make some sort of fake sky. So we're going to call that sky, and we're going to go to assets, create a new folder called materials. And I'll check the chat in a minute, guys. I just want to get a few basic things set up here, and I'll give you guys a chance to catch up as well. In here, we're going to create a new material called blue. And we're just going to set the main color to a nice sort of sky bluish color. And apply that to our sky. And then the sky, we're just going to move. We're going to set again the X to 50-ish, the Y to maybe 4. And we're just going to move it up. I'm just going to drag the Y here, and we'll move it forward. We'll move it on to 1 on the Z or Z axis. Let's move it up a little bit. There we go. So this is underground. This is above ground. Minimalist graphics here, but so it goes. All right. So now let me just take a quick look at the chat before I start scripting. And so you guys can, if you want to try to catch up, or feel free to just follow along. This will be posted on YouTube before the end of the week, and you can follow step by step then. But for those of you guys who want to follow step by step, go ahead and create our basic objects here: miner, gun, claw, origin. This is our, let's just call this barrier, the bottom barrier. Those are the things you kind of actually need. And then the sky you don't need. The gems are sort of a little bit optional at this stage. All right, let me just take a look at the chat. See how we're doing. Yeah, this is a very kind of flash game style thing. One screen, minimal kind of gameplay thing. I'm looking for ideas that I can do in an hour and get sort of working. So it's definitely not going to be Call of Duty. All right, so let's create a folder called scripts, which I've made in the wrong place. Put that in assets. And then inside scripts, we are going to create a new C# script, which we will call gun. And let's attach this to our gun. Derp, derp, there we go. And open it up in our beloved monodevelop. We're going to start by declaring some public variables. So we're going to have a public variable of the type GameObject called claw. This is going to be where we're going to store a reference to the claw that we're going to be shooting. We're going to have a public Boolean called isShooting, and this is going to become true when we shoot so that we can't shoot multiple times. We can only shoot once, and then we have to wait for the bullet or the claw to come back. We are going to have a public animator called minor animator, and we'll make the animation for that in a moment. And then we're going to have I'm going to make a note to just add the claw script here. I'm just going to make a comment there. I don't want to add it yet because I haven't written the script and it'll throw an error, but just a note there that we're going to come back and do that. Okay. We will delete the start function because we don't need it. And we can delete this comment because we know what update does. And in update, we're just going to check for input. So we're going to say if input dot get button down, fire 1. So if we've clicked the left mouse button and not is shooting. So is shooting, this is just a shorter way of writing is shooting equals false. So we haven't shot yet, or we've reset after shooting, so we're ready to shoot. Then we're going to call our function launch claw, which we'll declare right now. So we're going to have a private function that returns void called launch claw. And we're going to call that here. All right. So in launch claw, the first thing that we're going to do is we're going to set is shooting to equal true, because now we are shooting, the claw is in the air, and we don't want the player to shoot again. We are going to set the speed of minor animator to 0. So and actually, you know what, let me do this now just so this will be a little more easy to understand. Our minor is going to be rotating back and forth and automatically, and then we just click to choose when we want it to fire out the grappling hook. So super low input, kind of simple style of gameplay, appropriate for kind of casual games, right? Your kind of one button kind of games. And so what we're going to do is we're going to use some animation to do that. So let's highlight the minor. We'll choose window, animation. I've got my animation window docked down here at the bottom, but it doesn't matter. We are going to choose add curve, and then it's going to ask us to save the animation that we're creating. So we are going to call this rotation, and we'll store it in not in scripts. We'll store it in a new folder called animations. Save. And then here, what we're going to do is we're going to add some animation to the rotation. So we're going to unfold transform and click rotation. We'll expand this, and we're going to add some rotation along the Z or Z axis. So we are going to start off at -60, right? So rotate it over here. And then after 5 seconds, so we'll just drag this out. We'll zoom out with the mouse wheel here. After 5 seconds, we're going to return to -60. So again, we'll set this to -60, not -69, -60 to -60. So this will loop cleanly, right? It'll start and end in the same place. And then in the middle, we're going to have it go to +60. So it's going to kind of swing back and forth. And we can take a look. Let's go out of record mode and let's take a look at how that looks. There we go. So it's kind of swinging back and forth. And then when we click the mouse, it will fire off its grappling hook wherever it's pointing. And so what we're doing in our script is we're going to stop that animation, right? We're going to set it to 0 when we click the mouse, so it'll stop turning and launch out the claw. Okay, so the next thing that we're going to do, let me just see if anybody has any questions about that. We're going to declare a raycast hit called hit. Let me just check the chat before I keep barreling ahead. The turret will auto move. Yeah, the turret is always going to be moving, Ocarina of Time. It just keeps going until you fire, and then it stops moving. Let's continue. Thank you, Cap and Rat, for chiming in on that. Okay, so we got our raycast hit. So what we're going to be doing here is when we click, we're going to cast a ray into the scene, and then we're going to return a point where the ray hits, and that's where we're going to be sending the claw to, right? So we're going to store that in hit. Next thing we're going to do is we're going to declare a vector3 called down and set that to equal transform direction vector3 dot down. So basically we're going to store the direction down from the gun, right? So relative to the gun. So where it's pointing down relative to it, which will send a straight line away from the gun out into the scene. Then we're going to do our raycast. So we're going to say if physics dot raycast from, so physics.raycast takes a couple parameters, right? It's got from where, in what direction. We're going to give it an out parameter called hit, so we can return the value of hit in addition to the normal Boolean that physics.raycast returns. And there's also a distance variable. So we're going to start with, we're going to go from, no, not uppercase transform. Don't do that. From transform dot position in the direction down. We're going to return or store hit. So we're going to give our out parameter hit, and then for a distance of 100. Now 100, I just threw that in there just to make it go far. You could use mathf.infinity really, or specify, as long as it's long enough to hit the barrier or the things in the scene, it'll be fine. Now here we're going to say claw.setActive true. So what we're going to do is we're going to have the claw disabled until we're ready to shoot, and then we're going to set it active, and it's going to start moving using its update function. Now, I'm going to add another note to myself here saying call claw target from our claw script. I can't call it yet because we haven't written it, but I'm going to double back to this script and call claw target. And what that's going to do is pass hit.point, right? The point where our raycast hit, it's going to pass that to the claw to tell it where to travel to. All right. And then lastly, in this, we're going to have a public function that returns void called collected object. Now, notice this is a public function. That's because we're going to be calling it from the claw, right? The claw is going to tell the gun, I've collected something, I'm done, and then we're going to set is shooting to equal false and minor animator.speed back to 1, right? So basically, we're going to reset the turret. It's going to start moving again, and it's going to be ready to fire again. Okay, that should be good. Let's save that, jump back over to Unity, and in here, we'll add the needed references to the gun, right? So in, what did I get? Okay, the variable, okay, that's fine. So we're going to drag in our claw, which is a game object, right? We're going to drag in our minor, which is going to give us our reference to the animator component of minor, and that's going to be good. Next, we're going to write the claw script. Let me just take a look at the chat and have a sip of coffee before I continue. Ocarina of Time is asking, mathf infinity isn't much overhead. Yeah, I just set a distance there. I think that's probably the way to do it, because we don't need it to go for infinity. Yeah, the ray might keep going if it didn't hit anything. I mean, we set up the scene, so it will definitely hit something, but anyway, yeah. All seems to be well. Let me just play. Okay, so it stops, right, when I hit play. So when I click, when it's playing, so that is working thus far. And so now let's write our claw script. So in scripts, we're going to create a new C# script called claw. And open it up. And what we're going to do here is declare a bunch of variables. So we're going to start with our public variables. We're going to have a public variable of the type transform called origin. This is that empty game object we created. This is going to be where we're going to be firing from, right? It's a child with a gun, so it'll stay with the gun. We are going to declare a public float called speed, initialize it to 4. This is going to be how fast the claw is going to travel once we fire it. We are going to declare a public variable of the type gun called gun, right? That's going to be our reference to the gun script. And I'm just going to make a note here, add ref to score manager. We're going to add a score manager script later. Well, this would just be a variable. So we'll add score manager variable, just so I remember to do that. And then we are going to have some private variables. We will have a private vector3 called target, which is, no, not capital, lowercase target, which is going to be where the claw is traveling to. And that's actually what we're going to set from the gun script, right? We're going to pass in, when we call the claw target function that we're going to write, we're going to set that target variable to the hit.point of our raycast hit, right? So we're going to use the raycast to figure out where we're going and then set target in this script. Okay, so then we're going to have a private int called jewel value. This is just going to be used for the scoring system, and we'll initialize it to 100. This will be for the scoring system. We'll write the score manager in a bit. We'll have a private game object called child object. So the way that this is going to work is that when the claw collides with a jewel or a rock, it's going to make that object a child of the claw so that it can drag it back to the origin. And so we're going to get a reference to that so that we can destroy it once we're done. Destroy the childed rock or jewel once we're done. We are going to have a private variable of the type line renderer called line renderer. And so we're going to use the line renderer to draw a line, kind of like the rope between the claw and the gun. And then we were going to have a private Boolean called hit jewel. This we're going to set to true if we hit a jewel as opposed to a rock, and is going to be part of our scoring system. So we'll add points if that's true when we get back to the origin. And then we're going to have a private Boolean called retracting, which we're going to set to true once the claw is traveling back to the turret. Alrighty, so we are going to delete this comment, and we're going to change our start to an awake function. And in awake, we're going to get a component reference to our line renderer. So we're going to say, line renderer equals get component line renderer, and I'll add that when I get back to the editor, add that component to the claw. I haven't added it yet. We'll delete this too. And then we will, in update, what we're going to do is the following. So basically, we're going to do our movement code inside update. So we're going to say float step. We're going to declare a float called step and set it to equal speed times time dot delta time. So this is going to be how much we're going to move each frame, and that will become a little more clear in a second. So let me just write the next line. So then we're going to set transform dot position, the position of the claw, to equal vector3 dot move towards. So we're going to use this to move our transform, to move our position. So it's going to move from the current position. So you can see here we have 3 parameters. The first is current, the position where we are. The second is a vector3 target, which is where we're trying to go. And then the third is a float called max distance delta. And we're going to pass in step to say how much we want to move each frame, each time this script is run, or this line of code is run. So we're going to say, so we're going to transform.position is going to be the current position of the claw, right? Target is going to be where it's trying to go. No, not that. Then step will be the third parameter. So each frame is going to move from its current position towards target by step, right? In the amount of step. And so step is calculated from speed times time dot delta time. Time dot delta time is just going to make sure that we don't that if our frame rate is lower or higher, we're not going to change speed. So it's going to multiply the speed by basically the amount of time since the last frame was rendered so that we get a solid speed at whatever frame rate we're running at. Alrighty. Next, we are going to set the position of our line renderer, the first position of our line. So we're going to say line renderer dot set position. And we're going to set the first point in this line, which is going to be, or the 0th point, right? So that's the integer index in the line. And then the next thing is going to be a vector3 position. And in this case, that will be origin dot position, right? So we're going to be drawing our line from the origin to line renderer dot set position 1, right? The next point in the line to transform. Damn you, monodevelop. Transform dot position. So the current position of the claw. Okay. Now, okay, so the next thing that we're going to do, I'll set this up, but I'm not going to fill it in. I'll fill it in at the end just because it'll be a little more clear then. So we're going to check if transform dot position is the same as origin dot position and retracting is true. So basically, we're going to check if we've gotten back to the start while moving backwards. So we want this to evaluate to true to say the claw is done firing out and coming back, and now we're going to reset things. We need to check if we're retracting because otherwise it would become true as soon as we started the claw moving, right? Because it starts at the origin. So we're checking if it's at the origin and it's retracting, meaning it's coming back. It's finished doing its thing. So I'm just going to leave that open for now, but we'll fill that in a moment. Next, it's going to be kind of based on some of the other stuff we're going to do down here. So next, we're going to declare a public function that returns void called claw target, and that takes a parameter of the type vector3 called pos for position. So this is going to be the public function that's going to be called from the gun to set the position. So then all we're going to do in here is we're just going to say target is equal to pos, right? And let's actually set that up in the gun. We made a comment about it earlier. Now we're going to do it. So we're going to say we are going to have a public variable of the type claw called claw script. And we are going to, from claw script, we're going to call claw target, right? And we're going to pass in hit dot point, right? So the point at which our ray cast hit, right? So we cast the ray, it hits something, we store that in our hit, and then we pass that to the claw so it knows where it's going, and that is then set to the target where it's going to move towards. All right. Next, we are going to, let me actually, just before I write the next function, let's just take a look at the chat and see how everybody's doing. So, line render, so Losis asks, so line render will draw a line between miner and claw? That is correct. Yep, between those 2 points, which in this case correspond to the miner and the claw, or the gun, the origin point, actually, the empty game object we made. All right, great. So, let's keep it moving. So, okay, so we got our public function claw target. And next, what we're going to do is we're going to check collision on our claw. So we're going to have a new private function that returns void called onTriggerEnter. And this is part of the Unity API. You may have seen this before. And we're going to give it the parameter other of the type collider. And so first of all, now that we hit something, whether that's jewel, rock, or barrier, we're going to set retracting to equal true, right? It's going to start moving back. Well, the Boolean is going to become true, and then the target is going to be set to origin.position, right? So we're going to reverse the line. Was going towards the target. Now the target is the target that was hit by the raycast. Now the target is going to become the origin, so it's going to go straight back towards the origin. All right. Now, and that'll happen whatever it hits, if it hits anything, right? Now we're going to check for some specifical, which is really a word, not, for some specific things that it may have hit. So the first thing that we're going to check is if other.gameObject.compare tag, right? You remember, those who are watching closely, that we tagged our jewels with the tag jewel. So now we're going to check if the object that we hit had that tag, right? So if other.gameObject.compare tag jewel is true, we're going to say hit jewel is now true. So we hit a jewel. Next, we're going to set child object to equal other.gameObject, right? So we're going to store a reference to the object that we hit in child object, and you'll see we're going to later use that to destroy it. We're going to set the other.transform.setParent. We're going to set the parent, to this .transform. So basically what's going to happen, right, is when the claw hits an object, it's going to make that object a child of itself, if it's a jewel, and then start moving backwards, which is going to drag that object back to the origin. Now, if it's not a jewel, if it is instead a rock, else if other.gameObject.compare tag rock, we're going to do only these second two things, right? So hit jewel is not going to be true. Hit jewel is what we're going to use to score points, right? So if you get a rock, it's still going to drag it back and take a bunch of time, but you're not going to get any points for it, right? And this is kind of like the mechanical core of the game. You want to hit the jewels, not hit the rocks, and get as many as you can in the time allowed. All right. Now, let me just, so we called claw target and gun. That should be good. Okay, now what we're going to do is we're going to add our if statement. So now in there, we're going to call gun.collectedObject, right? That public function that we wrote in gun, which basically resets the gun, starts the animation going again. We're going to call that. Next, we're going to check if we hit a jewel. So if now hit jewel is true, right? We are going to, I'm going to make a note here. We're going to add points using the score manager. We haven't written the score manager yet. We're going to add that there. We're also going to set hit jewel to equal false. So we're going to call the add points functionality of score manager, but can't do that yet because we haven't written the script. So we'll just make a note to do that. Next, we're going to destroy our child object, right? So whatever we picked up, we're going to destroy it. We're done, right? We've returned to the origin and we're retracting. So now we're going to reset the gun, start it moving again, check if we hit a jewel, and destroy the child object. And then we're going to deactivate the claw. So we're going to say gameObject.setActive false. And that should be good. Let's save. Save the gun too, right? Don't forget to save both scripts since we changed them both. And let's see if we've added it to the... Let's add our claw script to our claw and set up our references. So we're going to drag in our reference to our origin and a reference to our gun script, right? Now we're going to add to the claw our line renderer component. So we're going to choose add component. Type line. There you go. Line renderer. And okay, we'll set up the line renderer in a minute. But for now, we can give it a test. Let's hit play. Whoa. Okay, that's not what it's supposed to do. Okay, we forgot to deactivate the claw. Let's do that. Let me just make sure I got my references set. That's that's good. Let's see. Boop. There we go. That's what I'm talking about. And then there's a null reference exception for what? Claw target. What did I miss here? That works. Not set to an instance of an object, you say. Oh, as you can see here, I failed to drag in my claw to the gun, right? Even after I made that variable, shaboop. There we go. All righty. So that, still not resetting. Oh, okay. Let's see here. This looks like, I think I may need to just, I think I need to just move my origin down a little bit. Yeah, I forgot to set the position of the origin. It's like colliding with itself. Let's see. Is that it? Boop. Yes, it works. So as you can see, right, if you miss, it's going to travel all the way down and come back. Takes forever. It's a big loss of time. So, and I suck at this game, by the way. I cannot win this game for my life. All right, let me take a look at the chat now that we've got that working. Oboe shape, I think that I have been told, I will say, that compare tag is more efficient than checking if other gameObject.tag equals, which is why I've recently started using it. I used to use the comparison, but now I'm using that because I was told it's faster. Oscar Russo is asking, won't that move the child object around? Yeah. So the question is, when you change the transform.parent, won't that move the child object around since the transform is relative to the parent and the parent is changing? If we're talking about the jewels and the rocks, we want to move them, right? We're trying to suck them back up to the mothership here, to the miner. So we could have totally made this game about tractor beams, by the way, which probably would have been way cooler. But anyway, imagination fail. Falcrons asked, is else if only used if there is one if statement within the function, otherwise multiple if statements? Well, let's see. The second, if you just had if, they would be evaluated sequentially, whereas the else will get skipped over if the first thing evaluates to true. Oh, Oscar Russo. Okay, you're asking. So Oscar Russo says, no, I meant you have a jewel in 111 relative to its parents and you reparent it. The position should not change when you set the parent. It will then, the transform component will then reflect the offset. So if it was like 5 units away, let's say on the X from the parent, it would now be at negative 5X. The transform would now reflect the distance from the parent relative to the parent. Yeah, you could definitely make the gems that have different scores. That will be very small jump from what we're going to show. All right, cool. Yeah, exactly. We can assign a script with a score property, or in fact, what did I do? Yes, that would be a good way to do it. I have an int for one score, but you could totally do that. Yes. Okay, so let's continue. So we're going to write a little score manager now, and we're going to do a little UI for that. So we are going to go to GameObject, UI, text, which will create the canvas and the event system that we need, and this will be called score. And we're going to set it in the upper left-hand corner. So I'm clicking on the anchor presets here, and then I'm going to Option or Alt-click on the upper left, which will set the position and the pivot. You can see it moves up there. We're going to set the text here to be score 0. We'll set the style to bold and the size to 24. And then we'll offset it. There we go. Set the alignment. And then I will set the horizontal and vertical overflow to overflow so that it doesn't disappear if it gets too big for the bounding box. And the color is fine. Oh, and speaking of color, well, I'll fix the line renderer in a minute. Then we're just going to duplicate that. I'm going to hit Command D on Mac, Control D on PC, and then we're going to, no, text, that's not what it's called. It's going to be called time. And we're just going to set it over here to the right. Again, just click on the anchor presets, Option click on the right there to set the position, and this is going to be time 0. So we need to change there. And then we're going to make 2 more things. We're going to duplicate time, and we'll call this U1. And we're going to set it in the bottom center. Again, option clicking. And I'm going to make this bigger. Let's make it 48. And the text here is going to be U1. Hooray. And we're going to deactivate that. Boop. And then we're going to duplicate that, and this one's going to be called Game Over. And the text will read Game Over. No exclamation point. We don't want to be mean, right? just regular game over. All right, there we go. So now we need a script to manage all this wonderful user interface functionality that we've added. So we're going to go to our script folder, hit create, C# script, score manager, and open that puppy up. And in score manager, we're going to add some stuff. We're going to add some public variables first. Actually, let me just check the chat before I keep going. Highly asks, why do we need to set the parent of the collected gem to claw? That is how we're moving it back to the turret. The claw is moving, the gem is parented to it, so now it moves backwards with the claw. All right, let us continue. So we're going to have some public variables in our score manager. The first, and perhaps most important, is going to be our score, and we're going to initialize that to 0, so integer score. We're going to have a public int target score, right? This is the score we're going to need to achieve to win. We're going to initialize that to 400. And we're going to have a public text. Okay, now here I forgot a step. The reason that text auto-completed to texture is because I haven't added the namespace declaration using Unity engine.ui. So without it, we can't access members of the UI namespace like text. So now we can have a public text, there we go, called score text. We're also going to have a public text called time text and a public int called time per level. We'll set that to equal 30. So that's going to mean we're going to have 30 seconds to complete the level. These are just going to store references to those two text objects that we just made. And then we're going to have a public game object called U1 and a public game object called game over. So we're just going to set these to active when you won or you lost. You could also totally, as someone in the chat was asking, just change the text in one object. One or the other way would be more easy, but this was just the way I thought to do it. So then we're going to have a private float called clock speed, which we're going to initialize to 1. Now, we're going to change start to awake. And in there, we're going to just initialize our, truthfully, we don't actually, oh yeah, we do need to do this. Score text.text is going to be equal to score colon plus our variable score, which stupid mono develop. That's perhaps unkind. But anyway, okay. So score plus target score, right? So we're just going to display our score. So 0 out of 400 points is going to be what we're going to initialize it to in this case. I'm just doing it that way because if you want to have multiple levels, you want to change the score as opposed to having it like as a string or something, or it's like a hard-coded string. And then, actually, we're not going to invoke repeating yet because we haven't declared this function. Let's declare it first. So we're going to have a private function that returns void called clock. And then in there, we're going to invoke repeating clock. So invoke repeating just allows us to repeatedly call a function. So we're going to give it the function name, clock, that we want to repeat. Time, the first time is a delay. So do we want to wait before we call this function? In this case, no, we don't. We want to start right away. And then lastly, we're going to use clock speed, which is the repeat rate. How long is it going to wait between repetitions? And that's in seconds. So in this case, it's going to wait every 1 second. It's going to run this clock function. And this clock function is going to be super simple. We're just going to say time per level minus, right? So we're going to subtract 1 from our remaining time. Update our time text to equal time colon space plus time per level. And then we're going to check if time per level is the same as 0. We're going to call our check game over function, which we'll declare now. So this is going to be void It's going to return void, check game over. And we're just going to use this to see when the game has ended, did the player win or lose, right? So the time has reached 0, the game has ended, did they win or lose? And so we're just going to call that once the time reaches 0. Okay. Now, in there, we're just going to check if score is greater than or equal to target score, right? Did we score enough points? We are going to set time.timescale to 0, meaning basically we're going to stop everything moving. We're going to sort of pause the game. U1.setActive true. So we're going to display our U1 message. Else, you did not win, sadly. We're going to set time.timescale also to 0 and game over.setActive true. True. The last thing that we're going to do in here is we're going to have a public function that returns void called add points. And we're going to access this from our claw. If you remember, I made a note to add this. It's going to take a parameter of the type int called point scored. And here we're just going to add score plus equals points scored, right? So we're going to add the points scored to our current score, and we're going to update the score text, and we can just duplicate this line here. Copy, paste, hooray, delete update, we don't need it. And delete this comment because cleanliness is next to godliness. Save, and now let's jump back over to the editor. Drop the score manager on the canvas, and let's drag our references. So we're going to have a reference to our score text, our time text, our U1 game object, our game over game object, and, oh yes, we just need to add to our claw a reference to our score manager. Here we go. Notes for the win. So we're going to have a public score manager called score manager. And here we're just going to say score manager.add points and pass in jewel value. Very good. Okay. Save. Now, almost done. So let's play. And fail. How did I fail this time? Of my many fails, score manager.add points. Jewel value. What did it say? Oh. Didn't drag a reference to the score manager, as usual. Drag in the score manager to the claw, right? So we can establish a reference to the score manager script. And let's see. And try it. Hooray! Our score is 100, and our UI is a little not beautiful there, but we can fix that. Ooh, and we didn't fix. Oh, fail! Boy, okay. So let's fix our line renderer. We'll make a material for this. Materials. Duplicate our blue material, and we'll call it black. And we'll make it black. Not completely black, just a whoop. Oh, that didn't work. You there. Oh, I added the wrong one. You there. Okay, there we go. Whoops. All right. Blackish. That's fine. Claw, line renderer, materials, right? Drag in the black in the material slot, element 0. And under parameters, we're going to set the start and end width. Right now it's 1 unit, right? It's basically the width of the cube. We're going to make it 0.1. And give it a try. Woohoo! So we got our nice thin black line. Very beautiful. You could add some kind of more fancy material to make it more tractor beamish, perhaps. And the fail again. Super fail. Okay, very good. I'm going to stop embarrassing myself there. All right, now let me just take a look at the chat. Let's see how we're doing time-wise. Okay, it's 4. Okay, I'm going to go a little over time here. I'm going to add one other thing just to spawn our jewels and rocks. Let me take some questions first, and then I'll do that. Hopefully you guys can bear with me as I go a little long. Okay. Yes, and I would just like to say +1. If you guys are writing lots of if statements, check out Switch. You will like it. Hannes B says, don't forget to stop invoke repeating. Yeah, you would use cancel invoke to do that, and that is a good point. Time.timescale does not freeze UI interaction. You can still interact with UI when the time... It might freeze animation. I think you would have to use it to switch to unscaled time, I think. Yeah, as Adam says, unscaled time. Very good. Okay, so let's do quick script on what we're going to do is we're going to spawn a bunch of jewels and rocks in random positions just to make this a little more exciting. So we're going to go 3D object, cube, drag in our black material, and call it rock. Tag it, rock, very important, and shaboop, drop it in our prefabs, and we can delete the rock and delete all these diamonds for now. Boop, get them out of here. And let's write a script. Scripts, create, C# script, and we'll call this spawn jewels and rocks, but we're not going to put that in the name. And here we go. All right, we're going to start with some public variables. We will have some, so basically what this is going to do, we're going to give some ranges, an X range, a Y range, how many jewels we want to spawn, and then we're going to use a for loop to place them at random points within a certain range of X and Y coordinates. Pretty simple script, but fun and useful for a lot of stuff actually. So public int, X range, which is going to be the range along the X axis. We're going to use the positive and negative values for this. So it's going to be from 10 to -10 along the X axis. And then we're going to do the same on the Y, public int Y range, which we're going to initialize to 3. Public int number of objects, which we'll initialize to 16. And we're going to have a public array of game objects called objects. This is where we're going to store our prefabs, and we're going to choose a random one of these every time we spawn. All right, we're going to delete update and declare private function that returns void called spawn. And we're going to call that in start. Spawn. All right. Now, in spawn, we're going to have a for loop. So we're going to say for int I equals 0 if I is less than or equal to num objects, right? We are going to I++, right? So this loop will keep running as long as we have as long as it has run for less than 16 times in this case. Then we're going to declare a vector3 called spawn location, spawn loc, and we're going to set that to equal a new vector3, which is going to be within a random range. So we're going to say random.range, really useful little function there, random.range between, so we're going to give 2 floats, and actually I should have probably declared these as floats anyway, it'll still work, between negative X range and positive X range. And then we could just duplicate that and switch it to Y, negative Y range, and positive Y range, and then 0 for the Z or Z axis, right? Because we don't want it to be moving forward and back from the camera. All right, so each time we run the loop, it's going to make a new location within those bounds that we specified. Then it's going to pick an object from the array. So we're going to declare an int called object pick. And that's going to equal another random number, random.range 1. So it's going to be between, the minimum will be 1, and the maximum will be object dot length. So depending on how many prefabs we have loaded in our array, it's going to choose a random number that is less than that. Then we are going to instantiate. So we're going to say instantiate. The game object we're going to instantiate is going to be objects index object pick. So basically we're going to instantiate the game object, which is at the randomly selected index object pick at the random location, spawn location, and then we're just going to use random dot rotation, which is just going to return a random rotation value to just give it a little random rotation, which is just cosmetic, but looks nice. All right, and that's all we need to do. Save. Jump back over. We will add this also to the canvas. And here's a little trick for filling arrays. What we're going to do is we're going to expand our objects array right now. Some of you might say, oh, let's type in the number and drag each thing in. Well, you don't have to do that. We are going to lock the inspector, go to our prefabs folder, and select, I'm going to select these 4, not the rock. You'll see why in a minute. And I can just drag all 4 of these in. Now, the reason I need to lock the inspector is because normally when I selected these, the inspector would shift to show those. But now it stays locked on my canvas, and I can just drag them right onto objects. Boop. And there we go. Now, I'm going to drag in the rock afterwards so that it will get put in the last position in the array. And then what I'm going to do is I'm going to change the size to 8, which will just fill those additional slots with the last entry. So we can just have half of the time we're going to spawn a rock and half of the time we're going to spawn one of these diamonds. All right, so now let's give it a test. Ta-da! A bunch of random rocks and jewels. Oh, look, and I got one. No, I missed again. And so, let's see if I can actually do this. You. Yes. And you. Okay, I'm going to have to get this. Oh, will there be time? The suspense. Oh, the failure and humiliation. And that is all we have time for today. We'll end on a low note. So hopefully that has been helpful for you guys and given you guys some ideas for your games. Let's actually, just to be sort of good and thorough people, let's get this score out of the corner there because that is not beautiful. We'll take the score and we'll give it a little bit of doobie-doo-wop. We'll give it a little bit of, let's switch to 2D mode, a little offset. There's the score. Okay, what we're going to do is, oops, sorry, canvas. What is going on here? Don't know. All right, let's leave that for now. All right, so let me take some questions, and maybe Adam can tell me what I'm doing wrong there, since Adam is our resident UI expert. I will put the scripts on the screen for those of you who want to copy. Put up spawn jewels first, and then we'll go back through, and I'll just take a look at the questions. See how everybody's doing. Yeah, actually, Hannesby is right. I totally should have used 0. Derp. Good point. That's going to leave out one of my elements here, the turquoise diamond. Let's see if it spawns now. There it is. Thank you. Good catch. Yes, thank you. Oh, unlock the inspector. Good idea. Oh, man, is that what it was? Durr. Thank you. Jeez. Of course, that was the problem. Unlock the inspector. Okay, so... Okay, this should work. Now the score is all the way at the bottom. Oh, that's why. Okay. Ooh. Not quite. What was that on? 0.9? And... derp. That's probably a little better. There we go. All right. Fixed it. Woo! Yeah. Struggle fest. It's new. The UI is new. Give me a break. The inspector is locked. Unlock the inspector, says the chat. Yes. Yes. It's true. It's true. It's like a horror movie. Don't go in there. Yes. Now we can make Scorpion from Mortal Kombat. Come get over here. Totally. Finish him. It's true, actually. Locking the inspector, I did that the other day, too, so it is easy to miss. Useful for failing arrays, but not so useful when you're trying to edit your UI. You know what I'll give you guys a tip on, actually, because I did this in the last tutorial. This does not solve the inspector problem, but if you... Where is it? Project settings? No. Is it preferences? The play mode tint. So this is something that I've done, right? I forget that I'm in play mode and I'm editing. You can set a play mode tint so that you can see that the editor is in play mode and not forget and do stupid things like make a bunch of changes to your project while it's paused and then forget and unpause and lose all your changes. Something like that for Locked Inspector might be kind of cool. Access Professor, thanks, man. I try to be funny and entertaining. We don't want this to be boring, right? Let's see. Michael Miko asks, please, Matt, can we use line render to draw a simple line, follows the mouse movement, and what if we want to know when it hits itself? Well, to make a, let's see, follows the mouse movement, you could make a kind of a stretchy line that would go from a point to the mouse, right? So almost like a rubber band. You would move the mouse away and it would draw a line between the point and the mouse. Now, if you wanted it to kind of like continue, if you wanted to make a curved line or like something like a drawing program, you would need to be dropping points all the time, lots and lots of points, so that it could keep drawing the line between those points. So, like you could in update, I don't know, this might be kind of not an efficient way to do it, but in update, you could spawn, I don't know, objects or record vector 3 positions for the line render to draw points between. I'm just kind of thinking out loud here, but, and then you would have this kind of, you could do, I don't know, maybe an array of vector 3s or something, or a list. Might work. Falcrons, yeah, definitely look at switches. Switches are cool. I was writing all these crazy if statements for a while, and then I learned about switches, and life got easier. You can also abuse switches. Ideally, you don't need like a million, 10K switches as well, but it is pretty handy sometimes. Drawing a line to the mouse pointer, you could use get position for the mouse and use it as the second point for the line. Totally. That would give you the stretchy line. If you wanted like a squiggly line, you would need to drop a bunch of points, but yes. T1-ish. If you want the changes to persist, there's an asset I think called play mode persist or something like that you can look for on the asset store. They did it. It's some people, there's been various talk about that, but I don't think that behavior is going to change anytime soon. Well, Captain Rat says we're working on it. There you go. That's a good sign. I take it back. Yeah. Michael Miko, drawing spirals, you're going to need to drop points for each point in the curve. It's going to be lots and lots of points if you want smooth spirals. Captain Rat says it's just not cool that Unity just kills all your changes like that. We're working on making that less painful. That's cool. That's good to hear. That's news to me. But neato. Laid Monkey, when is the next? We're doing these every Monday. Next one is we're going to do a kind of a similar little tiny game session next week with me, doing a little platformer thing, which should be fun. Another tiny game. I could actually hammer out the details for it, but it'll be fun. I promise you that. Granger73, thank you. What's the best way to change the spawner script so that the objects don't overlap when they're created? Well, it gets a little more tricky there. You could attach a script to the objects themselves and have them destroy anything that they land on top of when they're instantiated. I think that would work. You might end up with uneven numbers of objects. That would be probably the simplest thing to do. Or you would get into like laying out a grid and checking if the grid space is filled, and they would be like spaced more regularly, which might be nice too, gameplay wise. That script is, very simple and quick and dirty. I just wanted to throw that in there to get you thinking about, that's pure random generation, right? That's not, well, not pure, right? Because it's within range, but it's not like procedural generation where you would be massaging the data a little bit and exercising a bit more control. Alrighty. Since it's coming up on 4:30 my time and the chat seems to be slowing down a touch, I am going to shut down the microphone. I will hang out in the chat for maybe another half hour. If anybody has any other questions. Oh, sorry, I should have put the scripts up. These scripts will be, I'll put up the score manager for a minute. These scripts will be posted on the website, on the Learn site. You can copy and paste the scripts, and the video will be up there soon too, before the end of the week. And I will be back next Monday at the same time doing a similar tiny game session on a basic platformer. We'll do probably like jumping and collecting coins is what I'm thinking. A little Mario-esque kind of vibe. And that should be a lot of fun. So I hope to see you guys then. Thanks to the regulars for coming out. Always good to see you. And thanks for watching.